Hello everyone, my name is Prithvika K, student of Sri Venkateshwara College of Engineering, Bengaluru. Section Devu. I'm currently pursuing my engineering degree under CSE AI Stream. Course title Introduction to Civil Engineering. Course code BESCK 204A. Today's topic is about landfill and factors considered while selecting a landfill site. Concepts to be discussed under this topics are introduction, importance of landfills, types of landfills, factors affecting landfill selection, and conclusion. Introduction. A landfill system is a cornerstone of modern waste management system, providing a mean to dispose of any managed and vast quantities of waste generated by human activities. Essentially, landfills serve a designed area where solid waste is deposited, compacted, and covered with soil or other materials to minimize environmental impacts. This method is evolved over time to incorporate engineering controls aimed at mitigating pollution and health hazards. Landfills typically feature linear and leachate collection systems to prevent contaminations from seeping into surrounding soil and water sources. Furthermore, modern landfills often include systems of capturing methane gas production by decomposing organic waste, turning it into a valuable energy resource. Despite these advancements, landfills remain a less preferred waste management option compared to recycling and composting due to their long-term environmental consequences. Effective landfill management requires careful site selection, string management, regulations, and ongoing monitoring and safeguard public health and environment. However, challenges such as land segregation, regularity, and community opposition continue to shape the landscape of landfill systems globally. As society strives from more sustainable waste management practice, efforts to minimize reliance on landfills and promote waste reduction, reuse, and recycling are gaining momentum. Importance of landfills. Landfills play a crucial role in managing the disposal of solid waste, providing a controlled environment for the contaminant and decomposition of trash. They serve as essential infrastructure for handling the vast quantities of waste generated by human activities, helping to prevent the spread of diseases and environmental contamination. Landfills are particularly important in urban areas where space of waste disposal is limited, offering a centralized solution for waste management. Additionally, landfills contribute to reduction of greenhouse gases emission by capturing the mitigation of release of methane and potent greenhouse gas production during the waste decomposition. Properly managed landfills also support the circular economy by serving an repositories of minerals that can potentially be recycled or recovered in the future. While landfills are the valuable component of waste management systems, efforts to minimize waste generation and promote alternative disposal methods like recycling and composting remains essential for long-term sustainability. Overall, landfills provide a critical infrastructure for society's waste management needs, balancing environmental protection, public health, and resource conservations. Types of landfills. There are several types of landfills, each designed to address specific waste management needs and environmental considerations. Here are some common types. Sanitary landfills. These type of landfills are engineered facilities designed to minimize environmental impacts and protect public health. They typically featured linears at the bottom to prevent leachate, which is a liquid produced as a waste decomposes. From contaminating groundwater, sanitary landfills also have systems for collecting and treating these type of liquids and capturing methane gas produced by the decomposition of waste. Municipal solid waste landfills. These landfills are designed to handle household waste, commercial waste, and non hazardous industrial waste. They must comply with regulations governing the disposal of solid waste and typically incorporate environmental protection measures such as linear leachate collection systems and methane gas capture. Construction and demolition landfills. C&D landfills are specifically for waste generated from construction, renovation, and demolition activities. They may have different design requirements compared to municipal solid waste landfills depending on the types of minerals accepted and local regulations. Industrial landfills. Industrial landfills are used for disposal of non hazardous waste generated by the industrial process. They may require additional environmental controls and monitoring due to the potential higher concentrations of contaminants present in the industrial waste streams. Hazardous waste landfills. Hazardous waste landfills are specifically designed to handle a certain hazardous materials that poses a risk to human health and environment. These facilities must meet strict regulatory requirements for waste contaminant and monitoring and emergency responses. Bioreactor landfills. Bioreactor landfills used to control addition of liquids and air to accelerate the decomposition of waste, promoting faster breakdown of organic materials and methane gas production. This approach can help reduce the lifespan of landfill and enhance the methane capture of for energy generation. Composite linear landfills. Composite linear landfills utilize multiple layers of different materials such as clay and synthetic linears to enhance contaminant and prevent leachate from reaching underground water. Factors affecting landfill selection. Selecting an appropriate landfill site involves considering various factors to ensure environmental, social, and economical sustainability. Here are some key factors that influence landfill selection. Geological and hydrological conditions. The site should have stable geological conditions to support landfill infrastructure and prevent slope instability. It should also be located away from groundwater sources to minimize the risk of contamination. Distance from population centers. Landfills should be situated at the sufficient distance from the residential areas to minimize odor and noise nuisance and reduce potential health impacts on the nearby communities. Land availability and ownership. Sufficient land should be available for the landfill, and ownership or access right should be secure to ensure long time operation. Legal and regulatory consideration regarding land use and ownership must be also addressed. Accessibility and transportation infrastructure. Easy access to the site, roads, or the transportation infrastructure is essential for waste collection and disposal. This helps minimize transportation costs and environmental impacts associated with hauling waste or long distances. Environmental impacts assessment. Conducting a comprehensive EIA is necessary to assess potential environmental impacts such as air and water pollution, soil degradation, and habitat destruction. Mitigation measures should be identified and implemented to minimize adverse efforts. Last part of this topic, conclusion. In conclusion, the selection of landfill site is a complex process that requires consideration of numerous factors to ensure environmental protection, public health, and long-term sustainability. Geological, hydrological, and social consideration must be carefully evaluated to mitigate risks and conflicts associated with the landfill development. Additionally, adherence to regulatory and requirements and comprehensive environmental impact assessments and essential to obtain legal approval and community support for the project. By prioritizing the transparency and stakeholder engagement and responsible decision making, landfill selection process can contribute to effective waste management practices and promote the well-being of both current and future generations. This was the brief information on landfills and factors affecting landfill selection. I hope you people liked this video. Thank you for watching.